Hi, someone had this question on the homework, so I want to help you all figure out how to do this. So this is a bomb calorimeter, so you're going to need to know that the reaction that happened inside the calorimeter releases the same heat as the water absorbed and that the calorimeter absorbed. All right, so now the water is mass of the water times C of the water times delta T of the water. Now, the calorimeter is just B times delta T. This question is asking for the calorimeter constant, which is B. Right? The delta T is going to be the same as delta T for the water, so I'll just put a W here for you. Right? Let's figure out what the Q of the reaction is. We want to know what the B is. That's what we want to know. Q of the reaction we should be able to find from the given information. In fact, everything we should be able to find except for the B. We're going to solve for the B. All right? Let's go find the Q of the reaction. Why are we going to go find the Q of the reaction? Because if we know this and we know this, then we can solve for this. And this it contains the thing that we need to solve for. All right? So we need to know this and this. So let's go get it. The Q of the reaction. Where's the pen? Where's the? Oh, here it is. Okay, so the Q of the reaction. Q of the reaction. It's given. It says the heat of the reaction is this many kilojoules per mole. So it's negative 322. I'm going to need some more room. So the Q of the reaction is negative 3227 kilojoules for 1 mole. 1 mole of what? 1 mole of this stuff that we're burning, which is benzoic acid. Benzoic acid is a food preservative, and it smells really bad. So that's for 1 mole, but I'm not burning 1 mole. I'm burning this many grams. So I need to convert this to grams. But how do I do that? For 1 mole of this benzoic acid, how many grams is it? Well, I don't know the formula for benzoic acid, so I go on Google and I say molar mass benzoic acid. And it just tells me 122.12. All right, so where's the pen? Here it is. So 122.12. So now the moles cancel. I have grams. But that would give me kilojoules per gram. That's not what I want. I want joules for the Q of the reaction. So I'm going to get rid of the grams. I used 1.890 grams of benzoic acid, so I'm going to put that over here. This number is not related to anything. It's just how much benzoic acid we used. So I'm going to cancel these grams out, leave this just floating around by itself. And now I'm done with the grams, done with the moles. I just have kilojoules. But I want this to be in joules. Why? I want this to be in joules because the specific heat capacity that I'm going to use later is given in joules. So either I got to convert this to kilojoules or I got to convert this to joules. I think it's easier to convert this to joules. It's just a matter of opinion. So here we go. 1 kilojoule is 1,000 joules. All right. So the Q of the reaction is going to end up equaling this times this times this divided by that. I think that ends up being negative 49,900 something. This is a 4 significant figure problem. 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to need another significant figure. This is 3227 times 1.89 times 1,000 divided by 122.12. That's 49,940. 49,940. So that's joules, right? All right, so now I can solve this equation. So this is negative 49,940 joules equals negative Q of the water was the mass of the water, which is 900 grams, times the C of the water, 4.184, joules per gram per degree Celsius. That's given. Times the delta T, and that's given as 8.320. Wow, that's a fancy thermometer. It goes to the thousandths place. It increased, so this is the Q of the water, so it's times positive 8.320. So this is all multiplied in here. So that's all multiplied, and then all this stuff here, all this right here, all that is this right here, Q water, right? So I'm going to add the QB. QB, I don't know what QB is, all right? Actually, QB is B delta T. So I'm going to put B here, and I know what delta T is. So this is 8.320 degrees Celsius, right? All right, so now I have one variable, and I will now solve for this variable. So this is now let me rewrite this, clean this up so I can easily calculate. Where's the pen? Oh, here it is. So this is negative 49940 plus all these guys multiplied together, which is 900 times 4.184 times 8.32, and that's 31,330. So that's 31,330. All right, and that equals B times 8.320. So I'm going to divide both sides by 8.320. And that will get that will get B alone. So I end up with 2237, or I end up with 2237 equals B. And what are the units for that? Well, let's see. QB, this is heat, so that's joules. And this delta T, that's degrees Celsius. So I divided delta T on both sides, so that's going to be joules divided by degrees Celsius. So that's 2237 joules divided by degrees Celsius. All right, so this is a very, very hard problem. Thank you.